Hi guys, I'm Decisionate and I'm here to continue my lecture on glycolysis. This lecture is based on the pathway proper. I've explained the introduction in my previous lecture, but now I'll explain the pathway proper. this time. Then, as I've said before, there are series of 10 steps in glycolysis, starting from glucose as the initial metabolite. Glucose is the starting material and it is acted upon, as shown here, by the enzyme hexokinase or glucokinase. Please take note the distinction. Hexokinase, glucokinase. Hexokinase and glucokinase, they are both isoenzymes of each other. Hexokinase acts generally on hexose sugars, including glucose. It can also act on fructose, galactose, and so on. But glucokinase is more specific. It acts only on glucose. So for this first step, we can say the enzyme there can be hexokinase or glucokinase. But the pathway or the step, the name of the step is phosphorylation because it involves the addition or the transfer of phosphate group from ATP, which is adenosine triphosphate, to glucose to form glucose 6 phosphate. Then ATP changes to ADP, which is adenosine diphosphate. Please take note of the distinction. And if you check this first step, you also see a very important metal there called magnesium ion. This magnesium ion is what is called the cofactor. It's also called the cofactor. Why is it called the cofactor? Cofactor is an inorganic or metallic substance that assists an enzyme, which is the hexokinase or glucokinase, in its activity. Please take note. Then this glucose 6 phosphate is the product of this first step. And take note that this first step is usually important because when glucose enters the cell, to prevent the removal of glucose from the cell, it has to be activated. Hence the name, the first step, activation of glucose to form glucose 6 phosphate. Then the next step, which is step 2, involves a process called isomerization. Why is it called isomerization? It is called isomerization because glucose is changed to fructose. They are both isomers of each other. So glucose 6 phosphate is changed to fructose 6 phosphate. Please take note of the distinction. Then the next step involves another activation step or phosphorylation step. Please take note, this first step 1 and step 3, they are phosphorylation steps. But this specific type of phosphorylation is called substrate level phosphorylation. Please take note, substrate level phosphorylation, because phosphate is transferred from one substrate to another substrate, hence the name substrate level phosphorylation. Then at this step here, the enzyme here that catalyzes step is called PFK1. That's the abbreviation. The full meaning is phosphofructokinase 1. Take note, phosphofructokinase 1. Please don't confuse with phosphofructokinase 2. They are very different. They are isoenzymes. But this one is the special one that acts on step 3 of glycolysis. Please. Then the next step involves a splitting step. And this splitting step involves the breakdown of fructose 1,6 bisphosphate, which is the product of step 3, to form two important metabolites called dihydroacetone phosphate and glyceraldehyde 3 phosphate. Please take note. Fructose 6 phosphate, fructose 1,6 bisphosphate, sorry, has 6 carbon atoms. And obviously, when it is broken down, it is splitted or it is split into two molecules, and each of them possesses 3 carbons each. This one possesses 3 carbons, dihydrogen acetone phosphate. While this other one possesses 3 carbons too, glyceraldehyde 3 phosphate. Please take note. Now, the next step now involves the conversion of dihydrogen acetone phosphate to glyceraldehyde 3 phosphate. Please take note. This is step 5. This is step 4, which breaks down this fructose 1,6 bisphosphate. The step 5 converts this dihydrogen acetone phosphate to glyceraldehyde 3 phosphate. Please take note. Then after that step, the step 6 now involves an oxidation step. Not just oxidation, there's also phosphorylation in that step too. This oxidation is catalyzed or it is facilitated by the coenzyme called NADH or NAD+. A coenzyme refers to an organic substance that also assists in enzyme activity. It should not be confused with or confused with that of the cofactor, which is metallic in nature. This is organic in nature. Please take note. Then enzyme here that catalyzes this step is called glyceraldehyde 3-phosphate dehydrogenase. Please take note. It is called a phosphorylation and oxidation step simultaneously. Then the next step involves phosphorylation and is catalyzed by phosphoglycerate kinase. Please take note. And this step is the first step in which ATP is produced. And please take note, the ATP produced there are two ATPs produced there. I will explain why when I approach the end of this class or this lecture. Then the next step now, if you observe here, ATP or is formed as a result of the transfer of the phosphate group from 1,3-bisphosphoglycerate to ADP. One of the phosphates is transferred to ADP to form ATP. Please take note of that. And the next step now, I'm saying it involves the conversion of the product of this step 7, which is 3-phosphoglycerate to form 2-phosphoglycerate. And this step now involves a special form of isomerization, which involves the transfer of the functional group, which is the phosphate, from position 3 to position 2. Hence, the name mutis. Mutis is an example of an isomerase enzyme, but this involves the transfer of functional groups. Hence, the name mutis. Please take note. Then the next step involves a dehydration step. A dehydration step. Why? Why is it called dehydration step? Because one molecule of water is removed at this step. Enolis. This is the enzyme that catalyzes this step. It removes one molecule of water and it forms phosphoenol pyruvate. You can also call it PEP, but the full name is what? Phosphoenol pyruvate. The phosphoenol pyruvate is the penultimate intermediate because it forms the final product, which is what? Pyruvate. The phosphoenol pyruvate converts also to a phosphorylation step. This is the last step in which ATP is produced. Please take note. It is produced. Whereby phosphate group is transferred from phosphoenol pyruvate to ADP to form ATP. Please take note of that. I beg you. Take note of that, please. So now in this pathway, if you check well, this the red ink marker emphasizes the different phases of the glycolysis. The first one being the investment phase. Hence, investment means to put in something. What is being put in, or what is being put in into this pathway? What is put in is what is ATP. There are two steps in which ATPs two molecules of ATPs are put in. The first one is step 1. The third one is the second one is step 3. Please take note. First step involves the putting in of one ATP. The second step where or the second part where ATP is produced or is sorry where ATP is put in is step 3. Please take note by PFK1. The enzyme is PFK1. Please take note. Please take note. Then the payoff phase, payoff to pay somebody off to give something. So this payoff phase involves the phase whereby ATPs are produced. Adenosine triphosphate, energy currencies of the cell, are produced. For this payoff phase, the steps 7 and step 10 involve the production of ATP. Two ATPs are produced there, while two ATPs are also produced there. Please take note. I will explain why there are two ATPs produced in each of them. Now, normally in these pathways, if you check the arrows, there are some that are moving in one direction and there are some that are moving in two directions. Please take note. For the step 1, step 3, and step 10, they are usually called the irreversible steps. Please take note. They are called irreversible steps. They are shown in the body here. 1, 3, and 10. They are irreversible steps. And the other steps, 2, 4, 5, 6, 7, 8, 9, they are called the reversible steps of glycolysis. Please take note. And also, the irreversible steps, they are also known as regulatory steps. They are also known as regulatory steps. From the term regulatory, it means there are steps whereby the pathway, the rate of the pathway is regulated or is controlled. So these are the three steps whereby the flux of glycolysis is controlled. Please take note. Then, now to explain why there are two ATPs produced in each of these steps, step 7 and step 10, it's because from step 4 and step 5, for step 4, one molecule of glyceride 3 phosphate is produced from here. One molecule is produced. Then from step 5, the hydrogen acetone phosphate is also converted to form glyceride 3 phosphate. Hence, from this step 6 downwards, there are two molecules each formed. So if there are two molecules each formed, therefore it needs to from step 7 and step 10, two molecules of ATP will be formed and two molecules of ATPs will be formed here as well. Please take notes. Alright, that is all for now regarding glycolysis. So in case you have more questions to ask, you will contact us. This is Adrenaline Tutorials. You can contact us or contact me through this number if you have more questions to ask. So thank you very much. Stay blessed.